Today, for the first time, I started the stream earlier than scheduled. Nice. Yo, yo, yo. Hello, everyone. Hello, hello. Welcome to the stream. Today, we have a big day planned. We are going to finally start implementing the logic for our game. And I think this is going to be pretty cool. Last stream we had we wrote down the logic for the functionality we are implementing now, and we did so in GIMP, and we'll use that as a basis to implement the rest of the functionality we need. I will be opening up GIMP now because I don't have it open, but we have Parsec working with two monitors and Unreal and Visual Studio open. Which means we can dive right in. Let's do that. Let me find the file. Here it is. Here it is. So, a few things. The first thing I'm going to do here is to see how the basic mechanic was implemented in this example, so that I can use that as reference for my own implementation. So let's see. Let's go through Visual Studio Code now. So the Unreal Engine code always has two files. We have a H file and we have a CPP file. From my understanding, the H file is only the interface, and you can make stuff available to blueprints here as well, and you can use a bunch of specific Unreal code to make this work. I am not really sure of what those do, right? I'm not really sure what these pieces of code do, but we can always have a peek into the definition of them. We don't understand. I know that these are macros. Which means these are calls that will, in compile time, add a bunch of code to our code. So basically, all the code that the engine needs to run will be added through here with these macros. And yeah, and then in the CPP file, here is the implementation of the functionality itself. The first thing I will do is I will be let me see how the build works. It's cool that the build is in C#. I already have worked with C# in Unity, so that's pretty simple. Public dependent model, add range, new string, core object, engine input core, head mounted display. Okay. And then we have the H file for the puzzle game itself. And implement primary game logic, default game module, puzzle game. Okay, so I I would guess we don't touch these files. We start working from here. Puzzle game block, puzzle game mode, puzzle game pawn, puzzle game player controller. Okay. Okay. I will hit play here, and you will see that we can click the pieces and the pieces change color. Pretty simple stuff. So let's see how this is achieved. First, how do we insert those pieces into the game? Let's look. I'm not really sure if there is any blueprints here as well. Puzzle cube, the materials. I think, from my understanding, it's a good idea, a good practice to use blueprints even though you are working in C++, in Unreal, but it doesn't seem like the code here is using any blueprints. This is the starter content. This is something that always comes with Unreal projects. You can create projects without them, but you need to explicitly do that. And so these are the meshes and stuff. So it's doing everything through C++. I don't like that solution. I would prefer to have nodes available to execute the functions that I need and implement the general flow of the application through blueprints. That way, it's easier to modify the all the parameters, and yeah, and it's going to be easier to test out different styles of puzzles and such. I would very much like the game to the puzzle to work in the editor as well, in real time. So I will take a look into that, how to do that. Yeah, that's basically it. But I think we have good stuff here. We have, for example, how to instantiate objects into the world. I think, at least. Let's see. Let's take a look into this code now. So, here, uClass minimalapis. What is this? A block that can be clicked. Okay. A puzzle game block is the name. Public A actor. What is A actor? Game framework actor. What is this? Can I pick into this? The functions of interest to initialization order for an actor are roughly okay. An actor is an object that can be placed or spawned in the world. So pretty basic stuff. And then here we have the life cycles. So post load, post actor create, on construction, pre-initialize components, initialize components, post-initialize components, and begin play. Okay, those are the general life cycles we have available for actors. That's good information, good to know. Dummy root component, using component, dummy root, category block, visible defaults only. Blueprint Blueprint read-only. Meta allow private access true. Static mesh components for the clickable block. Okay. Block mesh. And these are pointers, by the way. Cool. A puzzle game block. Here it's in the public. I guess public is the of course this is the interface. So public are every function I will have access to, or method, every pointer as well that I will have access to through the game. Let's see, where is the hierarchy? Here we have lighting. We have render effects. We have camera. Puzzle block grid. Let's see. Puzzle dummy root. Score text. Okay. And here is the file. Puzzle game block grid. So I'm guessing this is the file that unravels the whole puzzle for us. Let's take a look into this. Let's take a look. Let me just check to see if... Yeah. Okay. It's working. I was just checking the bot on Discord if it worked. I think I'm going to change for a more chill playlist now, so we can concentrate. Let's do that. That seems like a good idea. Let's make sure everything is looking fine. Yeah. And let's take a look here. So it's including the actor as well, and it's including the puzzle game block grid dot generated dot h. What is this? Why do I need this? Oh, I forgot to sign in into Visual Studio. Just a second. I will change to the main camera here, and I will log in into my account. Dun, dun. I will probably I will have as this is the first time I'm working with Unreal, I will probably have to look documentation, ask a lot of stuff to ChatGPT to explain for it to explain to me. So yeah, I'm going to have to do that. Extensions here. Am I sign in? Yes, I am. Good, good. Now I can show you guys everything again. Yeah, here it is. Let's look. Puzzle game block grid dot generated. Why this dot generated dot h? Let's see. Let's ask ChatGPT for help. And here, I don't have music here. I know. I will add it really quick. Here it is. Yeah, there it is. And I will now restart the capture. Let me see, is this one the one I want, right? Yeah, this one is the one I want. Let's take a look here. Let's put it on something that's easy to identify. And where is browser group? Here. Yeah, this one. And let's now go to ChatGPT, new, hide this, and yeah, that's it. So I will paste the code I copied. I'm looking at this code as a reference for my Unreal Engine for puzzle game. I wanted to understand why we use this line. Let's see. In Unreal Engine 4, the line include puzzle game block dot generated is a crucial part of the Unreal Engine header tool system. Here's a detailed explanation of why it is used. Purpose of the generated .h file. Reflection systems. Unreal Engine uses reflection systems that allow the engine to introspect various C++ classes, properties, and methods at runtime. Okay, that makes sense. This is essentially for many engine features, such as blueprints, the visual scripting system, serialization, and property editor. Code generation. The generated.h file is automatically created by the Unreal header tool during the build process. It contains generated code that supports the reflection system, okay, such as metadata and boilerplate code needed by the engine. I will read this macros explanation, but that is all I needed to know about the question. The question is answered. And macro explanations. When you define a class with uClass, uStruct, unenum, or similar macros, UHT processes these macros and generates additional code, yeah, corresponding to .generated file. Okay, so the .generated file is the file where all the macros are executed and is the version of the, in this case, puzzle game block grid that the engine reads to run the code. I understand that. Yeah, I understand now. Perfect. We can proceed. So minimal API, yeah, is this what it needs? Minimal API. Maybe there's another way to instantiate a class that has access to more stuff from Unreal. That's cool to know. Generated body, okay. U property, category grid, visible defaults only, blueprint read only, meta allow private access true. Using component. The dummy root of the component, understood. Text component for the score. Okay. I see. Then a puzzle game block grid. And how many blocks have been clicked? Number of blocks along each side of the grid. Size. Spacing of blocks, category grid. Edit anywhere, blueprint read only, block spacing. Okay. And then protected begin actor interface, end actor interface, begin player override, virtual void. I don't understand this. Let's ask ChatGPT this one part. What about the code snippet within protected section serves several important purposes in Unreal Engine 4 class structure, specifically for classes derived from A actors. Access modifiers protected, okay. Begin A actor interface and end A actor interface, okay. Virtual void begin play override. The virtual keyword indicates that begin play is a virtual function, okay, meaning it can be overridden in a derivated class, okay. The function returns no value, okay. Begin play. This is the function. This is the function name, okay. Is a built-in Unreal Engine function that gets called when the game starts or when the actor is spawned. The override keyword ensures that this function is overriding a virtual function in a base class, in this case a actor. It helps catch errors at compile time if there is no function to override in the base class. Okay, good to know. The begin play function is a key part of the Unreal, but okay. I understand. Perfect. So that's the reason. And then we have handle the block being clicked, add score, returns dummy root object, using get dummy root, get score text. Okay. This is the block. Now let's take a look into the block grid. Oh, this one is the block grid. Okay. So let's take a look into the logic here. So this is the initialization, I believe, right? This is the constructor, basically creates a dummy root scene component, creates default subject uScene component text dummy 0, root component dummy root, create a static mesh component. All this is for the score text, okay. So the here this text here, just a second, this text here, this one, this is what it's being created here. Create default sub-object ut text render component, okay. Set relative location, perfect. Set relative rotation, okay. Set text, understandable. Setup attachment, dummy root, okay. Then attach that to the dummy root created before, perfect. Set defaults, size 3, blocking space 300 F, okay. Begin play, okay. Super begin play, number of blocks, loop to spawn each block. Get word, spawn actor, a puzzle, game block, block location, F rotator. Okay. Huh. Puzzle block grid. Yeah. Dummy root and the text there. Yeah, that's the stuff that was created. And then when I run the game, we have puzzle block grid here, and then it instantiates the all the other parts, but they are all just left here in the inspector. I thought it would be a good idea to at least group them, but it doesn't seem like it does that. Maybe there is a way to do it, maybe not. But this is a really good example. I just need to see a puzzle game block. Here it is, a puzzle game block. Constructor helpers, object finder, UI static mesh, plane mesh. Okay. So here it's how it's done. Perfect. I understand that. Yeah, that makes sense. Okay, so I think now I can start to implement my own version of this. Let's do this. The first part is for us to create the yeah,